This is IB Chapter 20, and it's on statistics, and this is going to be Section A, Key Statistical Concepts. And we're going to start off just by defining a bunch of things. So first of all, we have population, and that's the entire collection that you're interested in studying. The entire collection. So like if you were trying, maybe you wanted to know something about all of the high school students in the Matanuska Valley. That would be the population. Every single high school student in the entire valley would be the population. And then a census is if you were to like survey every single person in the population. So it's a gathering of info for the entire population. Because if you think about it, when our government takes a census, every single person has to fill out one of those forms, or at least every single person has to be accounted for on the form. A sample is a random subset of a population. Because often the population is so large that it would be very time-consuming or expensive or even impossible to collect the data for every single person or entity. So we just take a random sample, a random subset. And then and the survey is collecting the information from the sample. Collecting info from the sample. I'm writing kind of sloppy so I don't take up too much of your time. Alrighty. I'm kind of trying to do the same order that the book does. Then they say data. That's pretty obvious. That's just information. Numbers. It could be any information you're collecting. Then the variables. There's categorical. My pen is not calibrated very well. And there's numerical. And the numerical one is probably the most obvious. It involves a number. And since it's a measurement involving a number, it's something that can be measured or counted. So it arises from counting or measuring. Measured or counted. I'm not making, and I could copy these exactly out of the book. So if you want, the formal perfect definition, look in the book. Categorical would be like a description like, for one thing, it's non-numerical. For instance, of course, I'm thinking horses. A breed of a horse, or maybe the coat color of the horse. And then what's next? Okay, parameter. Parameter versus statistic. They're very similar, but there's a key difference. So a parameter is a measurable characteristic of a population. The population is key there. And a statistic is a characteristic of a sample. So it's a number that summarizes data from a sample. And examples of both of these, it would be like the mean, or the standard deviation, I'm going to abbreviate it as D, standard deviation of the population. That would be the parameter, and then the statistic would be the mean or the standard deviation from the sample. So an example would be if a researcher wants to estimate, let's see, can't even read my own writing. I came up with a good example and I can't even read it. Oh, okay, a researcher wants to estimate the average height of women aged 20 years or older. From a simple random sample of 45 women, the researcher obtains a mean height of 63.9 inches. You know, I meant to type that all up ahead of time so you could see it, because that's a lot to write down right now. But I guess I better do it. So we want to, I'll just kind of paraphrase it a little bit. Estimate the average height of women, and it doesn't even say, you know, which women. Maybe it means from the whole world, of women aged 20 years and older. And then there's a random sample. They take a random sample of 45 women and find the mean height is 63.9 inches. So that's the situation. And I really need to calibrate this, but I don't want to stop and interrupt the tape to do that. So if you were talking about the parameter, if you were asked to, describe what the parameter is, that would be the average height of women age 20 years and older, 20 plus. So in this case, the parameter, all we can do is describe it. We can't actually say what it is. And then the statistic, because there was a sample taken, we can actually say what it is. We could say the mean height of 45 women is 63.9 inches, and that's the that's the statistic. So hopefully that helps you see the difference between the parameter and the statistic. Statistics you can actually calculate often because you have a survey of a sample, whereas a parameter you're not going to be able to calculate it usually because it involves too much, because it's involving the entire population. Okay, next is darn, I lost the thing. Oh, distribution. So the distribution is a pattern of the data. Let's see, is that how I wrote it here? Oh, pattern of variation of the data. So, for instance, there's three that you usually see. Symmetrical is the first one. So that would be like if you had an x-axis here and it was just like a nice curve there. And then the others are skewed. So one of them, that's my x-axis, could look like that. And then the other one would be skewed the other way. So those two are skewed. This one is skewed to the right, and the book calls it something different. I think they say it's positive. Yeah, positively skewed. I'm in the habit of saying skewed to the right, so I'll try to remember that's positively skewed, and this one's going to be skewed left or negatively skewed. And then the final definition is an outlier. Like it sounds, they're outside. They're kind of like outcasts. They're different than the group. So they're either much larger or much smaller than the group. Than the rest of the data. And you should include them in your analysis, unless you know for sure that they arose from an error. So include in the analysis unless they arose from an error in the data collection. So yeah, if there was an error in the data collection, from an error. Well, cool. We got through. Oh, there's actually some more things we have to talk about. Okay. Couple more definitions real quick. The numerical variables. I thought I was done with definitions, but alas, no. So there could be discrete versus continuous. Discrete arise from counting. And continuous data arises from measuring. So things you can count would be like number of desks in a room. Whereas the continuous would be the height of the desks. And yeah, so continuous ones, usually we have to bunch them into sets, like from, you know, like maybe 20 to 30 inches. And then another group would be 31 to 40 inches. Whereas with discrete data, you don't have to put them into little bunches like that. Into class intervals, that's what the book calls it. Okay, next we have, okay, so frequency tables. Probably the easiest way to talk about these is just to actually make one. And what I thought I might do, just for fun, is go to our calculator and we'll generate some, generate some data on our calculator. I'm going to probably have a challenge with this though, because my board's not calibrated very well. So I'll try my best. See, it doesn't want to clear. Okay, so what we're going to do is we're going to go to apps. Good. Oh, it doesn't have probability simulation. Bummer. Well, try it on yours. You can go to, I'll talk you through it because I have my other TI-83 here with me. So forget that. Clear. So go to apps. And way down there, you have to go way down, past the languages, periodic, polysim. Well, of course, I suppose it depends on your calculator. But you go way down, and you'll find probsim. So hit enter. You have to press any key. And then it will say simulation, and the second option is to roll dice. Now I want to, so I'm going to go down to the second option, roll dice, and then it says OK. So I'm guessing this is true for the 84s as well. Hopefully it's formatted the same. And we could do this in class too if you want. There, on the OK, you're going to press the Y equals button because you're using like those top 5 buttons to press. And then it says escape, roll, set. Oh. Let me try roll. Darn, that's not what I wanted. I think oh, there. The first time you roll, then it gives you those options. Okay, never mind. Just a sec. I'm going to escape. Or, no, that's not what I want to do. Escape. Hold on a sec. I'm getting back to, okay, so roll dice, number 2. Okay. don't press anything. When you get to this, escape roll, set, data, TABL, table. Since I want to have it roll the dice several times, I'm going to have it roll 10 times so I can make a little frequency table. So to do that, you would choose set. So you'd press the zoom button, because the zoom button is right underneath where it says set. Oh, maybe this isn't going to work how I intended. Maybe that's just not going to work. All right, never mind. Forget that. You have to do roll, and it's just going to roll 1 at first. So roll is the window button. And it says, then it gives you the option of doing plus 10. So I'm going to press plus 10, which is the zoom button, and it's going to do 11 total. So I'm going to go to my next page, and like I said, we'll just do this in class as well. But so what I've got here, I'm going to make a frequency table. So this is the number on the die, because we're rolling it once each time. Then we're going to do a tally. And then we're going to do, so this is 1, 2, 3, 4, 5, 6. Then we're going to do a frequency. And then we can also do a relative frequency. So according to this, I kind of have to look at the table to figure out. But it looks like there was 1, 1. And then there was a 2. There were 3, or no, there were 2 3s, so you would do 2 ticks. There were 2 4s. There was 1 5. And there were 4 6s. Of course, in practical applications, if you're doing this by hand, each time you rolled, you'd do a tally mark. Frequency is just adding them up. There's 2, 2, 1, and 4. And then you do want to find your total frequency. It should be 11. It is. Darn, I wanted to do 10 so I could do the frequencies really fast. Let's cheat a little bit and pretend that we only did 10. And I'm going to just take one of the... Whoa. I share this board, so I never know for sure what's going to happen here. Let's say that there were 3 6s. That way I have a total of 10, and it's way faster to figure out my relative frequency. So the relative frequency would be 1 out of 10, and then you could say that's 10%. So you could either write it as a fraction or a percent, or a decimal for that matter. This would also be 10%. This would be 2 out of 10, or 20%. 20% again, 1 or 10%. And 30%. And these need to all add up to 100%. And they do. So just through this example, you can now see the tally, the frequency, and what the relative frequency is. And that brings us to making some graphs or displays. Oh, and escaping out of your probability simulation is a bit of a pain. You have to go through a whole bunch of things. Quit. Yes, I want to quit. Oh, let's use this data and let's graph it. We'll show how to graph it, and I'm sure this is actually fairly easy to do, so I need to keep track of these numbers. 1, 1, 2, 2, 1, 3. That way I don't have to flip back and forth. So first of all, there's 2 types of graphs. The column graph, which I'm kind of thinking we normally call the bar graph, and then the histogram. And the difference between these are really similar. The difference is the histogram, the bars touch, and on the column graph, the bars do not touch. Bars not touching. So we could use this for our data, the number of rolls. So we had 1, 2, 3, 4, 5, 6, and then on here we put frequency. Make sure you label your axes. And the highest one we had was 3. So 1, you just go up to 1. Whoop. Keep in mind this is not calibrated, so it's not doing too good of a job. And then there were 2 3s, and there were 2 4s, and there was 1, 5, and there were 3 6s. So how would you describe this? I'm seeing this sort of thing. Skewed left, or negatively skewed. Negatively skewed, in other words. So it's definitely not symmetrical. And our book says that the column graph is used for discrete. I do believe it said that somewhere. Yeah, discrete data. Although it seems to me like you could use a histogram for discrete data also, but anyway. And then if you were doing, so since I had discrete data, then I made a column graph, so beautiful. And then the histogram, they're saying you want to use that with continuous. I would definitely agree you would want to use a histogram for continuous data regardless, no matter what. But it seems to me like you could also use a histogram for discrete data. That's just my own personal opinion. And I'll just make up an example. If it's continuous data, like say you're measuring, I don't know, heights of something, and so you could have 10, 20, 30, 40, 50, 60. Let's say these are heights in centimeters of some object. And maybe you had 3 items that were between 10 and 20, so you'd have, a height of 3. Maybe there were 2 in this one, and maybe 3 again in this category, and so on. 1, and let's just do 2 again. So that's how that would look. You would still have frequency on the y-axis. And notice the difference too when you're doing these are called the class intervals, by the way. The 10 to 20 and the 10 to 20, 20 to 30. And the other thing too, when you're labeling these, you'd have to decide, are you going to make it like that? Your one side's going to have to be greater than and one's less than or equal to, or greater than or equal to. So this could be like, whoops, that should not be there. Something like that. These are called class intervals. And the class intervals have to be of equal width. Must be of equal width. So those are a couple of important things to realize. Oh, and another definition I just noticed. This data here would actually be considered bimodal. The mode is the most common. Like up here, the mode would be 6 because it happened the most often. Down here, there are 2 columns, 2 class intervals that happen most often. So that's why it's bimodal. There's 2. And then if we had like a really tall one here, then this, the tallest one is going to be the modal group or the modal class. And the very last thing is an example. Example 1. I'm skipping the case study. We'll just go straight to the example and then that'll wrap this up. So example 1, a sample of 20 juvenile lobsters is randomly selected from a tank containing several hundred. Each lobster is measured for length in centimeters, and the results are, and they have all these values. Oh, I should have planned this. I should have written this up ahead of time, because that's a lot of numbers to write down. But I guess here we go. 4.9, 5.6, 7.2. You could also look in your book if you wanted to. Apologize for not doing this ahead of time. These ones, okay, well anyway, 4.2, 6.6. Okay, I'm writing fast. There we go. There should be 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18. Okay, we're good. so first of all, we're going to organize this in a frequency table and then graph it. So what we have to do, because this is not discrete, you have these points, so you have to decide how you want to divide up the classes. And the rule of thumb is to try to get around 6 to 12 classes total. So you want about 6 to 12 class intervals. So you want to look at your min and your max. So our smallest one is like 3.1. Here's our smallest one here. And our largest, I see a 7.3, I think is the largest one I'm seeing. Well, 3 to 7. By the way, how many numbers is that? And it's not 4. What you do is you do 7 minus 3, which is 4, but you have to add 1. So there's actually 5. There would be 5 intervals. If we just did like from, say we do from 3 to 4, 4 to 5, 5 to 6, 6 to 7, and 7 to 8, because I have numbers bigger than 7. So I've got about 5 intervals. That's not bad. And notice how I've written them here. So these would be the lobster lengths, or whatever they were. Yeah, lobster lengths. Tally. That would be going through here and tally them all in. So you can do this too, and then pause the tape and do it on your own if you want. 4.9, 5.6, 7.2, 6.7, 3.1, 4.6, 6 is going to go down here, 5 is going to go here, 3.7, 7.3, 6, well there's lots of 6s, 5.4, 4.2, 6.6, 4.7, 5.8, 4.4, 3.6, 4.2, and 5.4. Then we can write our frequencies. So there's 3, 6, 5, 4, 2. And you might be wondering if, should you make this one be the less than and this be the less than or equal to? I think just kind of looking at the book, I would say probably they tend to do it this way. I'm not going to say they always do it this way, but it kind of seems like this is the way that they tend to do it. Okay, let's count these up and make sure there's 20. Let's see, 9 and 9 is 18, 19, 20. Okay, we're good. And does it want a relative frequency? Let's look. Frequency table, and then graph the data. So I'm going to erase the data now, and I'll put my graph over here. Let's make it bigger. I'll go to another color too, just to make it different. Red is nice. And my modal, my class intervals are going to go down here. Now, because this is continuous, it's going to be a histogram. You can go 3, 4, 5, 6, 7, 8. And then these bars are going to run in between these. And the highest frequency I have is 6. 1, 2, 3, 4, 5, 6. And then label frequency here. Okay, we've got from 3 to 4, we have 3 of them. Oh, my pen is really bad. 6, 5, 4, and 2. And they all touch. And you can see that it's positively skewed too, because it pretty much goes like that. Does it ask us for that? Yeah, it's going to ask us for that. State the modal class. So the modal class is the most often. It's the highest bar. It's from 4 to 5. So the modal class is from 4 to 5. And then it's skewed positively, so positively skewed. And anything else? I kind of think that does it. Yeah, make sure your modal classes are of equal, oh, not your modal, I keep saying modal. I mean, the class intervals are all equal, which they are. I mean, you had to set it up that way, so I'm just kind of hitting some highlights. It looks like we're done.